Hello, everyone. Thank you for joining us. I'm going to give it about a couple more minutes and then we'll get started here, okay? Thanks for your patience. All right, it's 1 o'clock, so we can get started. Hello, everyone. On behalf of the Environmental Finance Center Network, welcome to our webinar today on the NPDES permit developing process. My name is Maya Bani from the Syracuse University Environmental Finance Center. Before we begin, we're just going to go over a few housekeeping items and then we can get started. During the training today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes the link to the recording and other information you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This session has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for the session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of this webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us, the Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I'll be sharing shortly in the chat. And on that note, we can get started. I would like to introduce our presenter for today, Mike Tate, a professional engineer for the Wichita State University Environmental Finance Center.
All right. I guess we got people on about every time zone, at least registered. So good morning or good afternoon, wherever you might be at. My name is Mike Tate, and hopefully be able to help you understand a little bit about maybe how an NPDES permit is developed. There were some questions that people wanted some information on how that is done, and I will try to bring my 35 plus years of experience in the NPDES program to bear in doing that. I would say that this is an overview of how those permits are developed. Some folks from EPA or the states may have been privy to EPA's Permit Writers Workshop, which goes on for 4 days. And we certainly can't compress all of that into 90 minutes, but we'll do the best we can to get an overview of what's going on. And I think, Maya, before we jump into it, you want to run that first poll question and see what our audience looks like.
All right, the first poll is underway, and the question is, where are you employed? And the options are local government, industry, state or federal government, consulting, and other. All right, closing the poll in 3, 2, and 1. All right, 45% said state or federal government, 24% said local government, 15% said consulting, 10% other, and 6% said industry.
Okay, well, that gives us a little bit of an idea of who's with us today. And so again, this presentation is going to be about developing those national pollutant discharge elimination system permits. It's going to focus mainly on the publicly owned treatment works or municipal dischargers. However, others can benefit by understanding how permit limits are developed, particularly for industry or other commercial entities. Really won't delve into stormwater permitting either on this. And this presentation generally discusses NPDES permitting in terms of the federal authority, EPA, or state permitting authorities who have those programs, although do recognize that tribes and territories can also seek permitting authority. But about anywhere you see state, you could sub in tribe or territory when discussing the authorization of NPDES permit programs. Kind of the outline of what we're going to do today is just a very brief background on the NPDES program. Next topic is going to talk about the applications that are submitted to help develop the permits. And then the real meat of it's the permit limit development process, then the other components that make up an NPDES permit, and then NPDES permit public involvement if we have time. And if we don't quite get to that, it's pretty self-explanatory, and I would encourage you to download the slides from the GoToWebinar control panel you see there, and you'd have those to access later. But anyway, let's talk briefly about the NPDES program. We're going to talk about a little bit about the statutes that brought the Clean Water Act as we think of it today into being, then the regulations that further refine what the Clean Water Act expresses it wants to see in terms of the NPDES program, state authorizations, and then state water quality standards, because they do play such a key role in what we do in permitting. Some people would say you could go back to 1899 for one of the first laws, the Rivers and Harbors Act, which started talking about wastewater in the U.S. We're going to start here at 1948 with the Federal Water Pollution Control Act, and that provided some federal and technical assistance and funds to states who wanted to go about protecting water quality. And then in 1965, there was what was called the Water Quality Act, and that charged states with setting water quality standards for interstate navigable waters, those that ran across borders. You don't want to pollute your neighbor's waters. Maybe you're willing to do so on your own, but it was kind of set up to begin looking at those downstream neighbors and make sure that you weren't impacting their waters. And then in 1972, there was the Federal Water Pollution Control Act amendments that most people now will refer to as the Clean Water Act. And that was really the main act that created the NPDES permit program. It set up general goals and guidelines for permits to control discharge of pollutants, translate those permits, or to translate the requirements of the Clean Water Act and federal regulations into a document that dischargers can follow in order to comply. And then it also authorized EPA to let states seek authorization for NPDES permit issuance. Another big part of that was the construction grants program, which was used to build a lot of the facilities, some of which, at least in part, are still around today, and that were permitted initially under the NPDES program. In 1977, then the Clean Water Act had some additions to it that really looked at control of toxic pollutants. In 1987, you had the Water Quality Act, which was further more stringent regulations on toxic chemicals from industry. And it also moved from the construction grants program, where grants were given to individuals, municipalities, to build wastewater facilities, to what was called the Clean Water State Revolving Loan Fund, which then pushed more from grants to loans in order to build those facilities. And then in 2014 was kind of the last major amendment to that, and that was called the Water Resources Development Act, or you'll hear people call it WRDA, which set up the Water Infrastructure Finance Innovation Act, WIFIA, which is an alternate loan program, which is run by EPA. So those are the statutes really that got us to where we're at today. And the statutes, as most people know, are broad general laws and goals for what we want to achieve. Regulations then add more detail to that. So EPA was tasked with developing regulations to really implement the NPDES program. And those can be found in what's called, Title 40 of the Code of Federal Regulations, and primarily in sections 122 to 136. There's also information on what's called pretreatment, found at section 404, state sludge management or biosolids management at 502, and the federal biosolids management at section 503. Some of the key areas that you really want to focus on in 122 are those areas that cover the application and special requirements for permits. 122.41 through 50 are the permit conditions, which are very important. That's what you'll ultimately see come out in your permit that you have to comply with. And then the last part deals with transfer modification and how you might terminate or reissue a permit. And then a real key part of this in terms of permitting POTWs, or these municipal wastewater facilities, is Section 133, which is the secondary treatment regulation. And we'll talk about that a little bit later. And again, while tribes and territories can seek authorization, I'm generally going to use the term states, either EPA having authority or states, tribes, territories having authority to run these programs. And so Section 402B of the Clean Water Act says that EPA can authorize states to administer NPDES. And the law then really lays out the requirements if a state wishes to administer NPDES. And what that takes is a letter from the governor to EPA requesting approval of the program. State and EPA will develop a memorandum of agreement as to how that program would be operated. States provide a program description. States have to provide a letter or a statement from the state's attorney general that said states have the authority to legally implement the Clean Water Act. And the states have to have applicable state laws and regulations in order to do that. And if they meet all of that, then EPA either approves or disapproves their program within 90 days. Authorization does include public notification and comment, so the public also has an opportunity to weigh in on whether or not EPA should grant authorization to a state. Now, if the state does not seek authorization, then EPA is the permitting authority in that state. So currently, and I think this is still correct, that 47 states are authorized for NPDES permit issuance. And so I'd say there's about 48 different ways that NPDES permitting can be implemented. It has a general backbone that each state can do things a little bit differently, and EPA can do things a little bit differently. And that is really a good thing because states tend to want to take the programs and issue permits to be able to tailor them to their local conditions. So that's really a positive thing and not meant to be facetious there at all. However, while we say states are authorized for NPDES, not every state is authorized for every part of the NPDES program. You may not know that there are multiple program areas under NPDES. There's the base program, which allows an authority to issue individual permits to cities or industries. Then you have to apply to be able to issue general permits. And general permits cover a group of similar types of permittees. You have to be authorized for the pretreatment program, or that's to control those indirect dischargers or industries that might be in your town that connect to your POTW and may interfere with it. You also have to be authorized to permit federal facilities, those that are owned by the federal government, which quite often you'll see military bases, Air Force bases, Army outposts, what have you, as federal facilities. And then you also have to be authorized to issue permits under that Section 503 or biosolids program. And states can be authorized for all or some of those NPDES areas. And I hope the map is still accurate. This is from EPA's website, and it shows which states are anywhere from fully authorized to partially authorized to unauthorized. So you can see there's the 3 unauthorized states, 13 have partial authorization, and 34 have full authorization. And from my experience in Kansas, I should say I worked in Kansas for around 31 years, is that Kansas is partially authorized. They don't have authorization for the pretreatment program or the biosolids program. Now, they work hand in hand with Region 7 in order to implement those, but they're not authorized for those 2 parts of the program. And so while NPDES is implemented by EPA unless states seek authorization, the Clean Water Act puts the lead in developing water quality standards into the hands of the individual states. And it says, you know, states must develop water quality standards for their states. And those water quality standards, however, have to be submitted to EPA for approval or disapproval. And if EPA disapproves, they may take an action to promulgate or put into federal regulation a water quality standard for a state. But by and large, those are generally found in state rules. They're supposed to be looked at every 3 years and updated as need be to bring those up to current thinking on what water quality should be. And I bring this up because water quality standards play a very big role in most, I'd say most NPDES permits. They're going to play a very big role. And that's because you don't want those discharge of pollutants to cause a water quality standard to be exceeded in a water body. If it does, then it means it's probably going to impair the use of that water body. So water quality standards have various components to them. And the first thing is what's called designated uses. And that's the uses that a state want a water body to support. So if you go out, you look at a river or a stream, you say, well, what do I want to be able to do with that water? And, you know, 99.99% of the time, you're going to have aquatic life support. You're going to want to support aquatic life in that water. You can have recreational support, drinking water, human health. So these waters can have one or many of these designated uses. So the next part of the water quality standards is the water quality criterion. Now, so a lot of people think of that as the standard because that's usually the number. What value do I have to meet in the water, to meet my intended use? And so you set those criteria to protect each of the designated uses. And aquatic life, frequently comes into play in permits because that should be on almost all your water bodies. And those aquatic life criteria then have a couple of components that are important that we'll, hear about later how those are used. And that's as an acute criterion, which protects against mortality or death of organisms in the water body. And then you have chronic water quality criteria, which protect against mortality and growth and reproductive impacts. You don't want a pollutant to be there in such a concentration that it might stunt the growth of an organism, or it might cause them to be unable to reproduce or cause reproductive issues. So those are the kind of the things we want to look at there on the aquatic life. And the aquatic life also, on those acute and chronic components, have three things they've got to look at, which is magnitude, frequency, and duration. So magnitude means how much of a pollutant, what concentration will protect a designated use. And then there's the frequency. Well, I set that number, but is it just instantaneous that it causes an impact? Can it happen every day, every other day? So how often is that magnitude exceeded is referred to as the frequency. And then the duration is for how long. Again, is it instantaneous if I exceed that magnitude, or does an organism have to be exposed for 2 hours, 4 hours, a day before you have that impact? So those are all things that go into these acute and chronic criteria for aquatic life. And then the last part of the water quality standards is something called anti-degradation, which we'll talk about later, which is meant to maintain high quality waters. And while it's in as a water quality standard, it almost always implements via permits. So you'll see how that can impact permits later. And so, again, we'll see later, particularly how water quality standards go into the development of limits. So Maya, if you'd want to run the second poll question now.
All right, the second poll is I am, and you are selecting one of the following: an operator or a utility city manager, a state or federal regulator, a consultant, or other. Closing the poll in 3, 2, and 1. The results for I am are 38% responded a state or federal regulator, 19% said other, 14% said a consultant, another 14% said a utility or city manager, and another 14% said an operator.
Wow, even numbers. How about that? All right. Well, good. I think there'll be something here for everybody on this. And so we're going to jump into the second topic here, which is the NPDES permit application. And what we're going to do is try to briefly cover, who submits an application, what kind of application forms do you use, what application components are there for major and minor facilities, and signatories, which is very important. That's who signs an application. So who submits? Again, there's regulations for that. Under 122.21 says who needs an NPDES permit, and that's any person who discharges or proposes to discharge pollutants via point source to waters of the U.S. Short sentence, three key things: the person, the point source, and the waters of the U.S. So a person is really anybody or anything you can think of. It could be an individual typically, or it could be a business, it could be an industry, could be a city, just all kinds of things that qualify as a person. So don't think that it's one person, one individual who is applying for this permit necessarily. And then a point source, I'm not going to read all that. You can as to what's defined as a point source, but just think of it anytime you bring wastewater together into one conveyance and you get that to a water of the United States, that's pretty much a point source. And then the waters of the United States has been hotly debated over the past probably 15 years or more. And that's defined in 120.2, and I think they're still wrangling around as about what the exact definition of that will be. But your permitting authority can tell you if the water that you'd be discharging into is considered a water of the U.S. or not. And then biosolids facilities are regulated under Section 503. Now, EPA has application forms that can be used, and I have a table there on the slides, that breaks it down by what type of facility you are, and this comes out of EPA's Permit Writer's Manual, and you can see if you're a POTW with greater than 0.1 million gallons a day, there's certain forms you would submit. If you're less than that, different forms you would submit. If you're an industry, there's different forms you would submit. So there's lots of forms out there. And a lot of what they're doing is, acquiring information about your facility and any monitoring data you have on your effluent. Now, states can substitute forms if they capture similar information and if EPA okays those forms. And so you'll see a lot of states do their own forms that may be somewhat more abbreviated than the EPA forms. Some states will just use the EPA forms. The permit authority can also waive submitting effluent quality data if they already have that data on hand. And I'll use again an example, the state where I work, Kansas, maintains an electronic database of all effluent data reported by facilities. So it's really simpler for Kansas to work with the data to just pull it down electronically out of their own database and use it, but have to get EPA approval in order to make that waiver of that information. And then there's other general categories of information needed for POTWs. You're going to have the facility information like the location, name, mailing address, etc. You're going to have effluent discharge information. How many different discharge points do you have? In what state, what city, latitude, longitude, average flows, etc. You're going to have effluent monitoring if you have been an existing discharger, and you're going to also provide what test methods you use and how you acquired that data. And depending on the size of your facility, depends on what information then you have to submit. You may have to submit whole effluent toxicity data if you're a POTW with a flow of greater than 1 million gallons a day, or if your POTW has a pretreatment program, or the permitting entity may say, I want this whole effluent toxicity data. If you're even a small city, less than 1 million gallons a day, but you have a significant industrial discharger. And if you do have those industrial dischargers, then you want the name, address, information, and whether or not they have pretreatment, what are called local limits, or subject to categorical standards specified in federal regulation, needs to be submitted on the application. If you're taking a discharge from a hazardous waste generator or remediation site, that kind of information is needed. And also, if you're a combined sewer city, you have to have a map and information on those combined sewer locations. Now, the signatories, again, is this: who signs a permit application? And 40 CFR 122.22 really spells that out. It's simple for a corporation. Is you want somebody high up at the top of that corporation. You don't want to have the janitor, for instance, signing that permit application. So it's going to be somebody who has a pretty high rank in terms of the corporation doing that. We come down here for a municipality, state or federal. It's not quite as explicit. It just says a principal executive officer or ranking official is supposed to sign that application form. And that would be someone like the mayor of a city or a city manager, utility manager in that, particular instance. And I put a caution down here because I've seen it before that operators should not sign the application. It tends to be in a lot of small towns. They just kick everything down to the operator to sign, and that's really not the role of the operator to be signing the permit application. That should go to the mayor again or city manager. And I put one little caution because some of you, if you've worked in very small communities, there is an exception that sometimes the mayor is also the operator. And if that's the case, they would be signing, but they would be signing as the mayor and not the operator in that case. So that kind of wraps up, hopefully real quickly, the permit application and gets us into really what I consider the meat of the presentation, which is the actual NPDES permit limit development. That seems to be the thing most people are interested in. Why do I have to meet that number in my permit? And how did you come up with that number for me to meet it? And that's what we're going to cover here next. And so we'll briefly kind of look again at point sources and general versus individual permits, and then these things that help develop the numbers, those effluent limits, whether it's technology-based limits, a TMDL specified limit, or a water quality-based limit. Now, some people would argue that a TMDL limit's a water quality. They are based on water quality, but I think they're a little bit different, and I think you should look at each of them as you're going about the permitting process. And then we talked about anti-degradation before, and then we're going to introduce another term at the end of it, which is called anti-backsliding, which goes into figuring out that permit limit. So point sources, again, are that discrete source that carries your wastewater into a receiving water body, say a stream, lake, river, what have you. It's interesting to note that stormwater from municipality is considered a point source, and quite often, if you're large enough size, those are permitted. If you're agriculture and it's stormwater runoff, you're really not subject to NPDES permitting. And I would also note that some of these POTWs, or publicly owned treatment works, that do not discharge are not required to have a permit. Particularly if you're west of the Mississippi, you'll see lagoon type systems that actually evaporate as much water as they take in, so they never discharge. They might irrigate some of that wastewater. They might have some reuse of that wastewater. And in that case, they're really not discharging to a water of the U.S. and are not typically required to have an NPDES permit. However, I would say that most states then have a permitting program of their own, which is a state-only issued permit to cover those types of facilities. Now we're going to look at individual and general permits. Most of what this talk is around are individual permits, those that are issued directly to an individual facility. General permits, if you're familiar or unfamiliar with them even, are issued to cover a group or a class of similar dischargers. It means it's some type of activity that takes place that is very common between each of those dischargers, and so permittees will seek coverage under a general permit. Talk about that in a second. But individual permits, I'd say, take considerable time to develop. I think after we go through this, you'll understand why sometimes the regulator you're dealing with has to spend several months often in terms of developing that permit. And they are tailored to a specific discharger, and that's based on the type of discharge and the receiving water they're going to. So they also tend, as we showed before, to require one or more detailed application forms. General permits also take considerable time to develop, oftentimes more time to develop, just because of the broad nature and trying to make sure they cover all the bases for each of the people or entities that are subject to the general permit. But once those are issued, they can be used to cover multiple entities very quickly, since all the heavy lifting has been done in getting the single general permit issued up front. There's one thing I should say, that on both individual and general permits, they're subject to public notice, which means typically a 30-day notice to the public that you're intending to issue a permit and allow comment on that. Individual permit, each time they go out, they go to public notice. A general permit is issued once for the general permit, and then as it is used to cover the entities under the permit, a notice does not have to take place. So one general permit can cover hundreds or more entities, and they're often used, you'll see them for municipal stormwater. Pesticide application is another big one that's out there. EPA Region 8 has general permits for tribal lagoon systems that are all, pretty similar in how they operate and what they discharge. And then many states will use those for the confined or concentrated animal feeding operations, which also are fairly similar in how they're configured. And so once it's issued, again, on a general permit, an entity requests a notice of intent to be covered under the general permit, and those are typically fairly simple forms. And in some states, depending on the permit, you can get coverage in just a day or two turnaround. So that's the type of permits we have. Now we're going to get into really how do we go about calculating those limits. And the first thing we're going to talk about are technology-based effluent limits. You'll hear people call TBELs. So TBELs, if you are a minimum level of effluent quality that's attainable through typical technologies. Okay, and for POTWs, that's the secondary treatment TBEL, and that's defined in 40 CFR 133, and that's where you get the POTWs having a specified BOD, biochemical oxygen demand, total suspended solids, TSS standard, and a pH standard. When it was initially discussed, I think ammonia and some type of pathogen indicator like a coliform bacteria were also thought about being put in there, but it really winds up being the BOD, the solids, and the pH. For industry, the TBELs are industry specific, and those are typically found in 40 CFR 400 through 471, and those are specific to a specific industry. You'll find a whole set of rules for technology-based numbers for, say, petroleum refining or meat and poultry products, just a large number of industries that are captured under there. But so far as the POTWs, we have secondary treatment and equivalent to secondary treatment. And equivalent to secondary treatment, we'll hit here in a minute, is really only applies to trickling filters into waste stabilization ponds, or what I will call lagoons. But anyway, the secondary treatment requirements are that most people are familiar with are 30 milligrams per liter of BOD5 on a monthly average, 45 milligrams per liter on a weekly average. If you use CBOD or carbonaceous BOD5, you drop those numbers down by 5 milligrams per liter to 25 and 40. And then your TSS mirrors the BOD. It's 30 milligrams per liter monthly, 45 weekly. Your pH then is in the range of 6 to 9 standard units for either monthly or weekly. And then one that's often forgotten is the fact that you also have to have 85% or greater removal of both BOD5 and total suspended solids in your wastewater, which means you've got to get influent samples and effluent samples in order to assess that percent removal. Now, in the equivalent to secondary standards, again, those that apply to trickling filters and lagoons, the BOD5 is 45 milligrams per liter monthly, 65 weekly, 45 solids, 65 solids. Again, you see their pH remains the same, but the percent removal is dropped down to 65% or greater for those types of facilities. Now, you'll notice I had an asterisk here on the solids, and that's because lagoons can have even alternate standards, alternate total suspended solid standards than just the equivalent to secondary treatment. And that can take place if the lagoon's the primary treatment process. And what that means is you're doing most of your secondary or biological treatment in your lagoon. It's not that you may have a mechanical type plant before it that goes into a lagoon and then discharges. It means the lagoon's the primary treatment process. And that lagoon can't meet the equivalent to secondary limit of the 45-65. So back in the day, I think back in the 70s or maybe early 80s, states who believed they had lagoons who could not meet this equivalent to secondary number did really widespread studies on their lagoons and looked statistically at what they believed those lagoons could meet. They submitted that to EPA, and then EPA approved those alternate lagoon limits. And if you look in the various states, those range from actually 37 milligrams per liter to 120 milligrams per liter. And that's dependent on a state, so you have to look at each state's standards to see how they have set that up. Now, industries, are quite a bit different, and they're based on what a typical industry can achieve using particular technologies. And the industry specific are called effluent limitation guidelines, and they're based on really in-depth engineering and economic studies of the industry and the typical treatment that they apply. And this one is interesting, and note that it does have economic valuations placed in that too. And you can find most of this information in EPA's technical development documents for an industry. These are a really great source of information. They're very thick. It take a few days to read through them, but they can really help you understand an industry and what they typically do and the types of treatment they typically apply. And the thing that's interesting on some of these ELGs, these effluent limitation guidelines, is while we talked before in terms of just concentration, milligrams per liter on BOD and solids for POTWs, they may have some really interesting expressions of their limits, like the petroleum industry may have the maximum kilograms of a particular pollutant per day per 1,000 cubic meters of feedstock, or how much crude oil do they put through that refinery. And for some of the pollutants, then it's based on that value. Meat processing, don't want to upset anybody, but some of the limits are based on maximum daily pounds of pollutant per 1,000 pounds of live weight kill. How many, pounds of animals do they process every day? And that can help determine then what their technology-based limit is for certain pollutants. But the offshoot of all of this is that you really need to know the particular industry and how it operates in order to figure out what those technology-based limits are for the industry. And again, those EPA documents are very handy for helping understand that. So that's our technology-based numbers, that we've calculated. So we kind of take that technology-based number for each of our parameters, each of our pollutants we've learned through, and we stick them in a bucket and we set them aside on our desk, and then we begin to look at the next thing. And that is if there is a TMDL waste load allocation on the receiving water where you're going to discharge. So what do we mean by all of that? Well, total maximum daily loads come about because states are required to develop lists of impaired waters under Section 303D of the Clean Water Act. And impaired waters are those waters that don't meet their state water quality standards, even after you have point sources treating effluent. So there's still something going on that's causing that water to be impaired or exceed those water quality criteria that have been set by the state. So on a priority basis, states will develop these TMDLs, total maximum daily loads, for the impaired waters to try to come up with a recipe, if you will, for limiting non-point source and runoff and point sources, or your wastewater treatment plants, and limit those to the point that they believe, after modeling and other analyses, will cause that water to come into compliance with the water quality criterion. And so TMDLs for the wastewater treatment plants identify what are called waste load allocations, or WLAs, for the impairing pollutant. And you may have multiple waste load allocations because there might be more than one point source discharge in the water body that you're looking at. And so for non-point sources, they are given what are called load allocations. And those, for the most part, are not regulated like the WLAs are regulated. And then the TMDL also incorporates a margin of safety in it, because a lot of this is based on modeling. It's based on a big open environment where you've got lots of things going on. And so your models and all may not be able to account for everything. So you throw in a margin of safety into that to make sure that hopefully you will ultimately comply with the criterion. And for this, I like my picture I drew. Here's your waste load allocations from a municipality, a small one, a large one, and an industry. So they may all get a waste load allocation in there. You can have rural runoff, you can have urban runoff that may get load allocations assigned to them, and then you have a margin of safety. And so this total maximum daily load says I take all the waste load allocation, all the load allocation, throw in the margin of safety, and that's really the maximum amount of pollutant that could be put into a water body and still hopefully have it achieve its water quality criterion, which would mean that it would achieve its designated use. And that's the goal. That's what we're all after, is to make sure that waters can be used as we intend them to be used and not be impaired for any of those various uses. And so I say TMDLs are interesting. They're generally fairly long documents. There's a lot of work goes into them, and they tend to have to express the pollutant load in terms of a daily load, which is often a mass or a weight assigned to it. And so we know that a lot of the numbers, the values we work with, in our permits are in concentrations or milligrams per liter. So you have to understand how to translate that load that's specified into the TMDL into a permit limit. It's kind of this one load that's out there for it. So how does that translate into a daily maximum concentration or weekly average concentration, a monthly average concentration. And that's where I think the best advice you can give anybody is you want to speak with the regulatory agency who developed that TMDL and have them translate that. And that's what most permit writers will do is they'll go to the TMDL writer and say, hey, I've got a permit that addresses this pollutant. How do I put this in as a permit limit? So that's really key, is that you involve both people in that part of the process. So that's our TMDL based limit. Now, you realize that not every water is impaired. Not every water has a TMDL assigned to it. So you may not even have to deal with that for certain permits. But if you do, you've now got your technology-based limit you've set aside in a bucket. You've got your TMDL-based number you set aside in a bucket. And then you start working on the real biggie, I think, of all of those, which are the water quality-based effluent limits. And so real quickly, again, you remember when I talked about water quality criteria that states set those for specific water bodies, and they set them to protect various designated uses. So as you're, putting in an application for a permit to discharge to a water body, the first thing the state's going to do is say, I need to look at that water body. I need to look at my list and see what designated uses exist for that water body, because each of those designated uses may have a different criterion assigned to them. An example I'd give in Kansas is that you might have a water body that supports both drinking water use and aquatic life support use. And the chloride criterion for drinking water is 250 set in state regulation, while the chloride criterion for aquatic life support is 860. So if you have both of those uses, well, you're going to start out saying 250 milligrams per liter. I'm going to take the most stringent criteria for the most sensitive use in that water body. So we got to find all of those numbers that apply based on the designated uses. And then, as we talked about before, most of those water quality-based effluent limits for aquatic life, this one, will have an acute value, which again is that lethality, or it kills organisms in a short time frame, and that tends to be a larger value. And then you have the chronic value, which is the concentration of pollutant which will affect reproductive or have health effects on aquatic organisms. And that tends to be effective over a longer time frame, and it's a much smaller value typically because of that difference in the impact being reproductive in health as opposed to lethality. And so the water quality-based effluent limits, what you're trying to do, bottom line, is set them so that they won't be exceeded downstream of a discharger. And how's that done? Well, I have another picture that I like to use here. And this is kind of, again, here we got the city with the discharger and a whole bunch of numbers. So you can think of Q standing for flow, C standing for concentration. So you have upstream flow, upstream concentration, discharge flow, discharge concentration, downstream flow, downstream concentration. Now, you set up what's called a mass balance. If you took this plus this downstream, it should equal that value. So what do we typically know? We typically know the upstream value. Hopefully the state has sampling data and knows the upstream concentration. We know the discharge amount. We're told the treatment plant's going to discharge 1 million gallons a day or 10 million gallons a day. And this is what we want to know. So it's kind of an unknown here, that concentration out. We know the river flow downstream, if it's nothing more than the upstream flow and what comes out of the discharger, that becomes the downstream flow plus any other rivers or streams that would happen to come in before that point. And then this concentration downstream is kind of the starting point, is the criterion that's been set. If you just meet the criterion, then you should meet your designated use. You kind of hate to run it that tight, but that's how it would work. And so if you take this equation here and you solve for this concentration CD of the discharge, that's how you rearrange the equation and solve for it. So, I'd say, oh, that sounds pretty easy. Okay, I'll get all that data together. I'll find out what my criterion is, and I'll figure my permit limit. And then it's like, boy, there's more that needs to go into it. Remember that upstream flow, we're typically looking at a critical upstream flow, maybe not the whole flow. And I think everybody knows who's observed hydrology out there. The streams sometimes flow very low if there's a drought and very high if there's a large precipitation event. And so you've got to figure out what critical low flow you want to use. And what's often used, you will see, is what's called the 7Q10, or the lowest 7-day flow in a 10-year period, and that's hydrologically based. Or you can have one that's really probably better. It's called the 4B3, the biological flow. And that's the 4-day average flow event that occurs once every 3 years. And that's biologically based, and it tries to make more of an estimate of what the actual biological exposure of aquatic life is to that. So there's other numbers you can use. You'll often see with ammonia, it's based on a 30-day average. So you'll see a 30Q10 flow, the 30-day low flow in a 10-year period used. Now that number then, once you have that critical low flow, can even be restricted more. And that's if states have mixing zone rules that have been approved. Then that critical upstream flow, it basically says we're only going to allow a fraction of that flow to be used for mixing or, shudder the thought, dilution of what's coming out of that wastewater plant. And so the mixing zone applies to chronic criterion if you're talking about aquatic life. Kind of an example of that, and it can work different because they can have lengths and depths and what have you, but a real simplistic way to look at it is if you had 10 cubic feet of flow upstream and the mixing zone is 25%, you would only have about 2.5% flow then to mix or dilute that wastewater in. And then within the mixing zone, states will often set up what's called a zone of initial dilution, a ZID, where the acute criterion has to be met at the end of this ZID, and those are often, say, 10%, a very small fraction of the mixing zone, and the acute criteria have to be met at the end of that ZID or ZID. And then you think, okay, all righty, now I've got my numbers, I got my upstream flow, my downstream flow, we got everything computed, and now we're done. And I'd say, nope, just kidding. There's a little more to do to this process. And so for some toxics, states and EPA will take steps that are detailed in EPA's technical support document. I said for water quality standards, I believe it's water quality toxics. I may not have the title exactly right, but you can find that document pretty readily online. And what that says is that, due to the variability of effluent, it's not going to be the same thing every day. It is an average. So you're going to have some lower and some higher that they're going to be exceeded at some point. And so if you see this little short one here, this graph, this comes out of the TSD, that says there's a lot of variability. The coefficient of variation is 0.8. So even if the average is here, a lot of the times the values are going to be out here in this range. So you do a statistical calculation basically to back that value off so you minimize exceeding these concentrations out here on this tail on the right side. The TSD document also looks at whole effluent toxicity. And again, that's if you take the whole flow of your effluent and you expose in the lab organisms to that effluent. It looks at the overall impact, how a lot of different or all pollutants, together might affect organisms. And you do an acute test, which looks at lethality again to organisms, and a chronic test, which looks at reproductive efforts. Okay. So now we've taken that water quality base number, and for aquatic life, we've maybe then backed that off some more. So we don't exceed it more than a fraction of the time in our discharge. So now we have that limit identified, then we have to go look at what's called reasonable potential to exceed that water quality based effluent limit. And the federal regulations talk about a likelihood of a pollutant to cause or contribute to an excursion of a water quality standard. That, again, that's another kind of statistical manipulation that states are going to do. They're going to say, okay, I've calculated this water quality based effluent limit, taken all these steps we've done, and now you try to assess, hey, based on what that treatment plant puts out, will it ever exceed that water quality based effluent limit? Does it have a potential to exceed it? And if it doesn't, you'd say a limit's not needed. But if it does, then you should put that limit in the permit. And I even say here that sometimes you may have never measured a value as high in your effluent as what can be predicted as the estimated maximum value. And again, think about that curve we saw back on the previous slide. This is kind of a distribution of your data that's collected. And so you can think of this big spread here as the coefficient of variation. You got a long-term average, and you may have only measured right out here as the maximum value ever. But if you apply statistics to that curve, you could say, man, I could be way out here. So if I want to protect at the 95th or 99th percentile value, I could be out in this range. So you always want to check then to make sure that your calculated QBEL doesn't ever have a potential to exceed even out here on the extreme. And if you do have that reasonable potential, you should put the limit in the permit. If you don't, I think you'll often find states and EPA will just say, okay, I'm not going to put a limit in on that if there's not reasonable potential, but I want you to monitor for it. I want you to build up more data so the next time around we can check reasonable potential and have a bigger data set to look at. There's also narrative criteria and water quality criteria, and the narratives are often called these free froms, free from toxic and toxic amount, color, taste and odor, solids build up in the stream bottom. And you'll often see regulators just put those in the permits. They'll put that in as a requirement. So you should never have these things happen. And if you do, then it becomes a permit violation. Other times, they can try to translate those values into some type of numeric value. So we've now, what have we done? We've got, for the same pollutant, each pollutant of concern, we've looked to see if there's a technology-based number, EMDL-based number, and a water quality-based number. And so what do we do with that? Well, you can guess. You should choose the most stringent of those three possible effluent limits to make sure you're protecting for the most sensitive waters. And that's really kind of it, I would say. But then it's like, oh man, there's these other things that come in that really aren't the numbers or calculations that we got to consider, which are called anti-degradation and anti-backsliding. So when does anti-degradation apply? Well, anti-degradation is basically, you have to ask yourself three questions. Do you have a new or expanded discharge since your previous permit? And that's usually the trigger for it if you're going to have a new or expanded discharge. And is the discharge into a high quality water? And I think in most states you'll find you may not think a water looks very pretty or has anything special about it, but there's generally some pollutants that can trigger into this high quality water category. And then you have to even ask yourself the really basic question, is the lessening of water quality needed to accommodate important social and economic development in the area of that discharge? And that's actually an easier hurdle, I think, to overcome than you might think. But if the answer to all three of those is yes, then the permittee needs to look and see if there are practicable, less degrading alternatives. And practicable is a term of art. It's defined in this specific federal regulation. Dealing with anti-degradation is that it's kind of got to be technically possible and economically viable to have a less degrading alternative. That means basically, is there something out there exists to treat, and can it be afforded? So depending on state too, I would say be careful of how you look at expanded, because how that can apply. Do you apply it to concentration? Do you apply it to mass? Pounds per day of a pollutant or milligrams per liter. And I think a real good example of that is nutrients, which is one of our biggest concerns these days so far as discharges of pollutants from facilities. You might say, well, I got a 1 MGD plant, we're going to expand to 2. I have a limit where I'm meeting 10 milligrams per liter of nitrogen. So I'll just keep meeting 10 milligrams per liter of nitrogen, and I'm not going to increase that concentration at all. And then you think, oh, well, if you got nitrogen and you double the flow at the same concentration, you're doubling the mass of the pollutant. And for something like nutrient, mass is what's really important. That's what really causes downstream pollution. So in fact, you are expanding that discharge by doubling the mass of that nutrient, even if you keep the concentration the same. So you got to always be cognizant of that. It might be dealing with concentration. It could be dealing with mass. But again, then you can say if it's a renewal of a permit and there's no expanded discharge, then generally no analysis is required. If you do trigger into it, then you have to do an alternatives analysis, and that's the permittee does, and they look and they cost out less degrading alternatives if they exist. And then the alternative analysis is subject to public participation. You have to put that out for the public to review. And if it turns out there are practicable alternatives, the regulator should put even a less degrading alternative in, which is likely going to reduce that water quality-based effluent limit even more. So it could be smaller based on anti-degradation. And remember, you only get that if it's to accommodate important social or economic development. If there are no practicable lesser degrading alternatives, the regulatory authority can say, okay, you can further degrade the water if it's for important social or economic development in the area. So that's anti-degradation, and that's kind of a tough one. I don't think really understood real well overall, but it does come into play in those permits where you expand the discharge or if you have a new permit. And then anti-backsliding, how does that work in? Well, it says when a new permit is renewed or reissued, the limits in it must be as stringent as the final effluent limitations or standards or conditions of the previous permit. So essentially, all that's saying is you can't, except for a few prescribed reasons, raise the permit limit for someone in a renewed permit. They're going to have to meet that number. And if they've been able to meet it, you have to ask yourself, why would you want to lessen water quality? So it's really a good thing, I think, to protect water quality. But there are a few key exceptions to that where you may be able to raise the limit some, and that's this, I'll let you read them all, but the material substantial alterations. I've seen one before where a facility was meeting about 10 milligrams per liter of ammonia coming out of their plant. During the permit process, they greatly revised their plant. They began meeting less than a milligram per liter of ammonia. So it turned out they no longer had a reasonable potential to exceed the ammonia limitation. So that was able to be taken out of the permit. information available at the time the first permit was issued that's available now. That can be a change in how water quality standards are looked at. Administrator determines there's been mistakes of law. That's pretty self-explanatory. And then it says a less stringent effluent limitation over events where the permittee has no control. That's generally thought to be some kind of natural disaster, which I've scratched my head at how that applies, but I suppose it could. And then the last one is, hey, the permittee installed treatment facilities that were thought to be able to meet the effluent limitations in the previous permit. They've operated it correctly. They maintain their facilities, and they still haven't been able to meet the effluent limitations. Well, if all three of those things are met, then the permit authority can raise the permit limit up to the level of pollutant control that's actually achieved. Now, I have honestly never seen one of those myself, and so really the bottom line kind of comes down to is that if you calculate less stringent permit limits versus an old permit, it's likely the old limits are going to apply. There are those few exceptions, but that's really it. And so that brings us really to the end of how you draft a permit. And Maya, I think with that, I had that last third polling question.
All right, the question for this last poll is asking, developing NPDES permit limits are, and the options are easier than I thought, about what I expected, and more complex than I thought. Closing the poll in 3, 2, and 1. The results are 59% said about what I expected, 41% said more complex than I thought, and 1% said easier than I thought.
All right. Well, most people who thought it was easier than it takes a while, and I think it's good for operators, consultants, and cities to know that sometimes when it takes a while to get that permit from the regulating authority, there is a lot to go through, again, to try and make sure that you're protecting water quality with that permit. So we're going to try to go through real quick on some of the other permit components that you'll then see in your permits. We've kind of talked about how we did the effluent limitations, and then you have cover pages and standard conditions and supplemental conditions and pretreatment schedules of compliance and fact sheets. So pretty simple. Cover page, kind of name, location of the permit. Key point is that there's a statement from the state or federal regulating agency that says this facility described above is authorized to discharge wastewater from this location, with a signature of that regulatory official and the date, and then having the issuance and expiration dates for that permit. Limits, again, as we just discussed, technology, TMDL, water quality-based limits, and that's the primary mechanism, again, for controlling discharges. And those have to be expressed in the appropriate units, whether that's milligrams per liter, pounds per day, number per 100 mil for, say, bacteria. And you have to express the appropriate time frame. Is it a weekly, monthly, daily average number? That has to be expressed along with that number. And then, of course, you got to take into account the backsliding and anti-degradation. So the first kind of additional component there is monitoring and reporting. And so on the monitoring, it's, the numbers you got to meet. You got to tell people where to sample the effluent for that. And so you need to clearly state where the sample's taken and make sure it's representative of the treatment process. And it allows the regulator and the permittee to both monitor the same location every time. So you're always comparing apples to apples on your samples. And most times, all the samples are collected at the same location, but there could be different. You might have a compositor, takes composite samples you want to have up in a building at the end of the treatment process, where you might sample for BOD and solids and all those things at the end of the process. But you also have a DO limit, and you have an aerator that's put in down right at the discharge point to the stream or river. And that's where you would want to take the DO sample. So you need to specify very clearly on those where the sampling locations are. And you need to state if there's internal monitoring locations. And so internal monitoring locations means at a point not where it's particularly the wastewater that's been treated and it enters the receiving water. An example of that is sometimes you have two different treatment trains that might be subject to different effluent limits. A lot of people may have an old trickling filter plant, and they keep that and they treat a fourth of their waste through the trickling filters, and they may have another train or another almost treatment plant that's a newer activated sludge facility that's subject to different evals. And so you want to monitor each of those to make sure they're meeting their particular requirements, and then likely have a location down where the two streams combine, where you're monitoring as they impact the discharge to the receiving water. You got to tell people how often they got to monitor. Do you want a sample taken daily? Do you want it weekly, monthly, annually? What kind of sample is it? A grab sample where you just go out and take a single sample with a grab? Or is it a composite sample? You might use one of these compositors that grabs a little aliquot or a little sample multiple times during the day and then pours it all into one sample bottle. So you get really what the effluent looks like during the day all at one time. Is you could have some different values happening depending on which time of day you're discharging. And the best of those, why they can be time-based, you could set it up to take 1 hour. The best are the ones that are flow-based composite. Those, if you can hook them in electronically to a flow meter that grab a certain amount of sample based on the amount of flow that's growing through the plant, that will be your most accurate of all the samples and give you the best representative idea of what's hitting the receiving water. You're going to specify the analytical methods. Those are typically found in 40 CFR Part 136. Sometimes you need a minimum detection limit. Had a plant once that had a ammonia limit of 1. The lab was continually, they used a commercial lab that sent in data that our minimum detection's 10. Well, that doesn't work, and you can definitely get down below 10. They had to write into the permit that the minimum detection level they needed to hit was 1 milligram per liter, so we could see if they were complying with their permit. There's also reporting and record keeping requirements. A lot of that now is done electronically as you submit your DMRs electronically. Other information is submitted again, typically the month following when you took the samples. Sample or data has to be kept for 3 years. Date, time, place of sample, the sampler, analysis, name of analyst. And some of that, if you're using a commercial lab to do your data, you'll need to get them to supply that data to you. Typically they will. It'll come with your monthly reports from them, but you're the one who's important. You're the one who's required to keep that. So you need to make sure you have it. And one of the things I would tell you is a lot of times I see citations of permit noncompliance that has nothing more to do than record keeping. So really do make sure you understand the record keeping part of the requirements in your permit, because you're required to have them. And I would say you're required to have them, particularly if you have an unannounced inspection from a state or federal inspector and they want to see those records. It's up to you to be able to supply them to them when they're there. Then you have general or standard conditions, and those are kind of pre-established. Those come out of the federal regulations at 122, 41, and 42. There's a lot of them that you can read through on the handout that I provided, but a couple of them are that I think are important here in the orange. Or, you have a duty to reapply. If you have a permit, you have a duty to reapply on time for a new permit if you wish to renew it. Sometimes states will send those out automatically. They'll send you an application and a renewal when it's time. That's a courtesy on their part, and they're not required to do that, but you are required to submit on time. So understand that. You have a duty to mitigate, which means if, daily operation of your plant, or if something's upset, you take all reasonable steps to prevent, impacting the environment with your plant. Proper operation and maintenance. This is one that is sometimes a tough call, but it says the permittee has to properly operate and maintain all equipment. Now, sometimes plants will have redundant equipment, and so that if you're cleaning or maintaining one part, you switch over to the other side. That doesn't all have to be operated. That's not what this is saying, but it all should be maintained. I've been out, I probably can't count the times, to a plant that goes, well, that clarifier has a broken motor on it, and what are you doing with it? We don't have the money right now to fix it. Well, recall that your permit says that you are going to maintain that equipment in working order on that. You have a duty to provide information. That means if the regulator asks you for information about your plant, you're obligated to give it to them. Representatives of the regulator also have a right to enter and inspect your facility. They're supposed to present valid credentials if they do that, and it's supposed to be at reasonable times, but you are required to allow them in and allow them to inspect that facility. Monitoring and records, we've kind of gone over that again. That just covers again that you're required to keep records, and you're required to sample correctly under the Clean Water Act. Signatory requirements. Here we are again with signatory. And it says permittee must sign and certify applications, reports, and information. Knowingly making false statements and representations or certifications punishable by fines and imprisonment. And don't take that lightly. There are people in corporations, there are operators at municipal plants, there are other folks who have done prison time for submitting false statements, and it's really not worth that. Make sure that everything you're putting your name on and certifying is accurate and correct, even if it's a violation. It's better to be honest about it rather than to make a false statement and be subject to criminal prosecution. Plan changes, you need to notify the director, that could be of the state or EPA, if you're planning on making alterations to your facility, and they'll talk through what that takes. If you have anticipated non-compliance, you're going to take a part of your plant down, you need to make some repairs, talk to your regulator about that. They'll probably try to work with you. They may encourage you to work around the clock, 24 hours, to minimize the impact of that downtime. But that's, what they're going to try to do with that. If you have compliance schedules in your permit, there's a standard condition that says you'll report within 14 days following a date when you're supposed to do something required by that compliance schedule. You get 24-hour reporting if you think there's non-compliance that might endanger human health or the environment, and that should be done orally, a telephone call to the regulator, and then within 5 days, you need to submit a written report. This is a very abbreviated part of what's called the bypass provisions, and I've included what I think is important, and that says that a bypass is defined as an intentional diversion of waste from any portion of your treatment facility. And it says those bypasses are prohibited, and the director can take enforcement action against you if you do bypass your facility, but it gives some reasons where you may be able to do that. And that's if it was unavoidable to prevent loss of life, personal injury, property damage. A lot of times for those of you who are operators, it's interpreted as if you're going to wash all your biological solids out of your treatment process, you may be better bypassing than having that happen. You have to know that there were no feasible alternatives to the bypass. You didn't have some auxiliary tanks, or you couldn't have stored in your collection system more water, that it was just imminent and you'd had no other alternative but to bypass. And then that you submitted notice to the regulatory authority, and then the director of that regulatory authority may be able to approve that bypass. But just think, typically, you're not supposed to do it unless you can meet those conditions, and there's upset. Next, there's special or supplemental conditions that you'll often see in permits. And not every permit will have them because they're specific typically to that permit. That's what makes them special. And some of the ones you may typically see is there may be a requirement that you monitor the stream, not just your effluent, but the stream up or downstream of a discharge. You do a special study, like a mixing zone study, or you look at maybe the cost to reduce nutrients from your facility, and it may require you to take some best management practices. There's also what I'd call special conditions for those plants with pretreatment programs. And pretreatment programs are designed to prevent a pass-through of pollutants or interference of pollutants from a particular industry in your town. And so those may have special conditions regarding what you're supposed to do via your pretreatment program. You report that out to the regulator. And then kind of lastly here, we're talking schedules of compliance. Schedules of compliance are allowed to meet limits that you can't meet, with the exception of those technology-based numbers. The reason they're technology-based numbers is it says everybody should be able to meet them. So you should be able to meet those from the time you're beginning to discharge. And so typically those schedules of compliance are used for those water quality-based effluent numbers. And you're given a time for compliance. It's supposed to be as soon as possible. Given interim dates, don't exceed 1 year on those dates. And you'll often see requirements for reporting annually, just so you don't go past that 1 year date. And then again, you're supposed to report within 14 days of one of those dates to the regulatory authority, and also notify the regulator if you don't think you're going to be able to comply with your SOC, so you can talk out what needs to be done. And then, kind of to wrap everything up, you do what's called, typically on a major facility, you're going to do what's called a fact sheet. And that's kind of the factual legal methodology you use to develop the permit. You're explaining your rationale for deriving the limits. Remember all that stuff we went through, you should be able to explain to people. It's provided to both the discharger and the public. It has certain requirements, again, in federal regulation as to what has to be in there, like description of the facility and activity, sketches of it, types and quantity of pollutants. The key thing is really this detailed rationale of the permit conditions that are placed in there, from the limits to compliance schedules and anything else. And then that is available for people to see why you did what you did. And then it also has some administrative requirements that said you should put in that when the public comment period is, how somebody in the public could request a hearing, other procedures that are involved with your public participation, and really importantly is the name and contact for a person for additional information. If somebody has questions about it, who do they call, at that regulatory agency to find out what is meant by some of the things in that permit. For non-major facilities, the regulations require EPA issue statements of basis, and I call those a fact sheet light. They're only really required to explain the derivation of limits and the reasons for the limits and conditions. Most states will go ahead and do those, even though it's not required by federal regulation, because it's just good for them if somebody asks a question to have somebody develop that rationale and be able to explain it to the public. And I think with that, I'm going to wrap up on that. You can read from the slides that public involvement, it's just typically if you do a permit, you're going to put it out on public notice for the public to comment on. And if the public thinks there's enough of a concern about it, they can request a hearing. You have a hearing. The regulatory agency then decides, okay, based on all these comments I received, do I need to change the permit, not issue the permit, or issue the permit as is? And that's kind of the public involvement piece. So I think with that, I'd say if there's any questions, we can try to get to them quickly before we wrap. So Maya, were there any questions that came up?
Yeah, I have a couple questions here for you. First, I have, do the ELGs for industries stay the same per unit no matter how many units they produce, or can they increase in restrictions the more a product is produced?
They generally increase the more a product is produced. If you think of that, like I said, for the petroleum industry, it was kilograms of pollutant per 1,000 cubic meters of product. So if that they started running more product through the facility, they expanded it, they would get a larger number of kilograms of waste that would be the permit limit for that technology-based number.
All right, great, thank you. And then I have one more. It is, some EPA regions require a CMOM or a CMOM program as part of the NPDES permit. Is it a growing trend or still state specific?
That is state specific, and those CMOMs are usually, I'm trying to, comprehensive maintenance and operation. Gosh, not remembering the last M on there, but that's basically an operations plan for the sewer systems, and it's a really good practice to have. Although it is, I think, very state and very region specific as to when those are required. I know that those were not typically required in Kansas unless we had somebody with a very poorly functioning collection system, had a lot of infiltration, inflow, that type of thing. So they're not bad to do. I would encourage every municipality to have one to try to help ensure that their collection system is operating at peak performance.
All right, that seems to be all the questions I have for you at the moment here.
All right, well, I thank everybody for being here today, at a good crowd, and I hope I achieved what your intent was for listening to the webinar and getting an idea of what goes into NPDES permitting. And it tends to be a little more complex than most people initially would think that it's going to be. And so it does take some time for that regulatory agency, be it a state, tribe, territory, or EPA, to develop those permit limits and get it through the public comment period, public notice, and get those out. So know that there's a lot that goes in, but hopefully you know a little bit more about it now to where you can ask questions. If you're an operator and you see something in your permit you think's funny, the first thing I'd do is try to see if there's a fact sheet or statement of basis and look and see how that permit writer developed your permit and try to really understand what's required. And I hope for operators, particularly too, that you understand those requirements, particularly in the general conditions on record keeping, And some of those types of things, they sometimes go overlooked, but you're certainly on the hook to comply with those. So, always read your permit thoroughly and try to understand what's there. And if you don't, contact your regulator. They'll be happy to explain it to you.
All right, and if anyone has any further questions, feel free to submit them following the webinar, and we'll be for sure to answer those for you. Thank you, Mike, so much for sharing your expertise with us today. Following this webinar, you all will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar, so you can let us know your thoughts on today's session, as this helps us plan for future webinars on topics important to you. So thank you all again so much, and we hope to see you at future EFCN events.